Assalamualaikum warahmatullahi wabarakatuh. Good morning to all my students. Okay, today I'm going to bring all of you to what we call a discussion of one of the set that I have with me right now. So I do hope that this discussion or my explanation really helps you and benefits all of you in your preparing your before your final examination. Okay, so then this is a set of the question that I have with me right now. So, for your information, that for final examination of paper SM015, there are only one papers then, okay? And then they divide into two parts, which is part A, where there are three questions, one, two, three, and part B, there will be 7 questions that provide you 75 marks. Okay. For part A, they provide you 25, and for part B, they'll provide you 75 marks. Okay, there are 7 questions, all of them 1, 2, 3, 4, 5, 6, and 7. Okay, so for what we call Pspm, for this, we call for semester 1, contains of what we call question from topic 1, 2, 5, 8, 9, and 10. Okay, so class, let's get started here now. Let's start here. Okay, look at the first question here now. Limit of x approaching to 4 for x squared minus 16 divided by square root of x minus 2. Okay, so guys, girls, if I strictly substitute the value of x equal to 4 here and here, 4 squared equal to 16, so 16 minus 16 equal to 0, and square root of 4 equal to 2, then 2 minus 2 equal to 0. If it gives you 0 over 0, then the whole function is undefined or damaged, so we are trying to avoid this. Okay, do not strictly substitute the value with x equal to 4. So what are we going to do now here is we're going to multiply this with a conjugate of denominator. Then we have square root of x plus 2 divided by square root of x plus 2. Okay, so multiply this limit of x approaching to 4. Look at denominators here. Square root of x times square root of x here. Okay, because this is a conjugate, x square of x plus 2 is a conjugate for square of x minus 2. So it means that here, square of x multiplied with positive 2 and negative 2 times square of x, it clearly is 0 here. So then negative 2 times positive 2, it gives you negative 4. Okay, so then the denominators here right now, we have x minus 4. I think that we can form one of the linear for x squared minus 16, which is equal to x minus 4. Okay, x squared minus 16. X squared minus 16, we come up with x minus 4 and x plus 4. Am I right? X times x squared, 4x, negative 4x equal to 0, then negative 4 times 4 equal to 16. Then we have square root of x plus 2. So, clear between these two, x minus 4 divided by itself equal to 1 then. So, limit of x approaching to 4, we have x plus 4 and square root of x plus 2. So, what you get then? Substitute x with 4 here, 4 plus 4 equal to an 8, and square root of 4 equal to 2. 2 plus 2 equal to 4. Then it equal to 32. Okay. And then evaluate limit of square root of x squared minus 2 divided by x plus 2. This is a limit of x approaching to positive infinity and limit x approaching to negative infinity. Okay. So for B, limit of x approaching to positive infinity of square root of x squared minus 2 divided by x plus 2. Okay, so class, limit of x approaching to positive or negative infinity, we are going to refer to this x because we are going to divide every single term with the highest degree of x from denominator. And the highest degree of x from denominator is 1 here. But then, if you look at this, you might think that the highest degree of x, which is 2. But don't forget that square root of x squared is going to give you an x. Okay, so now for this one here, limit x approaching to positive infinity. So we have x squared divided by x squared minus 2 divided by x squared divided by x over x plus 2 divided by x. Okay, so we use these rules here. Square root of x squared equal to an x. So x is the highest degree of, we call degree, according to this question here, degree of x from denominator, which is power of 1. And this also considered as power of 1 here now. Okay, so x squared divided by x squared equal to 1. 2 divided by x squared equal to 0. Then here 1 and here is 0. So what we get then? It's going to give you square root of 1 minus 0 divided by 1 plus 0. So square root of 1 minus 0 equal to 1. So 1 minus 1, 1 divided by 1 equal to 1. Okay, then next, limit of x approaching to negative infinity, square root of x squared minus 2 divided by x plus 2. Okay, and again, this is, we call square root of x squared equal to modulus of x, where modulus of x, we divide into two parts here, where x for x greater than or equal to 0 or negative x for x less than 0. Okay, so now, for this case, limit x approaching to negative infinity, square root of x squared divided by x squared minus 2 divided by x squared divided by x over x plus 2 over x. And because we have x approaching to negative infinity, we come up with negative sign here. For this one, it's approaching to positive, so we add nothing. We consider this one as a positive here now. But for this one, we add up with a sign of negative. And then x approaching to negative infinity, for this one, we equal to 0. Okay, wait. It's not 0 then. This is 1. Okay. This is 1, 0, 1. And 0. So then it come up with negative square root of 1 minus 0 divided by 1 plus 0. Then it is equal to negative 1. So, from these two set of answers, which is 1 and negative 1, so we come up with a conclusion that horizontal asymptote, HA, for me, okay, I write it in short form, horizontal HA stand for horizontal asymptote. Okay, horizontal asymptote for fx, which is y equal to negative 1 and y equal to 1. Okay, so find the horizontal asymptote, if any. So this is the one, y equal to negative 1 and y equal to 1. Okay, next question. Find the derivative of the following function. So then y equal to 2x squared plus 1 divided by 2 to the power of 2x. Okay, so guys, girls, for this one, if we derive this or differentiate this based on the question here, because it's a ratio, then we have u and v. So y prime of this one, we come up with u prime multiplied with v minus u multiplied with v prime divided by v squared. Okay, but then if we modify this or make some adjustment here, 2x squared plus 1 and multiplied with 2 to the power of negative 2x. So this multiplied with this, then this we call dy dx or y prime for this one is come up with u prime multiplied with v plus u multiplied with v prime. Okay, so there are two different methods or approach that we can use it here. So then let's say if I use either one, okay, meaning that I can choose any of these two as a solution for this question here. Okay, let's say if I make it on the right side here then. So y equal to 2x squared plus 1 multiplied with 2 to the power of negative 2x. Okay, so y prime or dy dx equal to, firstly, we're going to differentiate this. 2x squared plus 1. Differentiate this, going to give you, yes, 4x. And then, okay, y prime equal to u prime multiplied with v plus u multiplied with v prime. Okay, I bring this above and here according to look at this one here now. So 4x multiplied with 2 to the power of negative 2x plus with 2x squared plus 1. Just now we differentiate 2x squared plus 1 to give you 4x. The next one, we just write this all here now, and it's time for us to differentiate this. Okay, class, y equal to a to the power of fx. Then y prime equal to, okay, firstly, we write down all this again, a to the power of fx. Multiplied with, yes, natural log of a. Next, differentiate the function of fx here, f prime x. So slowly, one by one, firstly, we can write down all this again, 2 to the power of negative 2x, then multiply with natural log of 2, okay, and differentiate this, differentiate negative 2x, it give you negative 2, okay. So then 4x, 2 power of negative 2, it means that is 4x divided by 2 to the power of 2x plus with, okay, so 2x squared multiplied with everything here, 2 power of negative 2x, natural log of 2, and then negative 2. So look at this one here now. Guys, girls, 2 power of negative 2x multiplied with natural log of 2 multiplied with negative 2. We cannot simply multiply between this negative 2 with 2 from the natural log here. No. Or this negative 2 multiplied with this 2 here. No. So guys, girls, what can we do here now is just let it be like this, okay, until the end of the solution then. So now, 2x squared, wait. I think that for this one, negative 2, we can multiply with 2x squared. So negative 2 times 2x squared, it should be negative then. Okay, 2x squared times negative 2 minus 4x squared. Okay, negative 4x squared. And then multiply with natural log of 2 divided by 2 to the power of 2x. And then 1 here. 1 multiplied with negative 2 minus 2. Okay, 1 multiplied with negative 2. Then natural log of 2 divided by 2 to the power of 2x. Okay, so simplifying all this, it's gonna give you, okay, look at the denominator, all of this with 2 power of 2x, am I right? Okay, all with 2 power of 2x. So then 4x minus 4x squared natural log of 2 minus 2 natural log of 2. And everything divided by 2 to the power of 2x. Okay, so you may factorize this. We have 4, 4, and 2. So take out the 2 here, and then 2x minus 2x squared natural log of 2 minus natural log of 2 divided by 2 to the power of 2x. Okay, and then between this, okay, we have natural log of 2 and natural log of 2. So then 2 class, which I think that for this time being, if you get this one, which I think that is more than enough, okay? But then according to this one here now, it is 2x minus natural log of 2 multiplied with 2x squared minus 1 and divide by 2 to the power of 2x. There you go. Okay, y equal to x minus tangent x plus 1 over 3 tangent cube x. Find dy dx in the term of tangent x. Okay, so this one here, y equal to x minus tangent x plus 1 over 3 tangent cube x. So then dy dx equal to differentiate of x equal to 1. Differentiate tangent secant square x plus with 1 over 3 is a constant. Okay, now for this one here, we are going to differentiate the power of this function first. 3 multiplied with 3. Then tangent 3 minus 1 equal to 2 x. Then differentiate the trigonometric function. Differentiate tangent secant square x. And differentiate x equal to 1. Okay, so now 3 divided by 3, we have 1 minus secant square x plus with tangent square x secant square x. Okay, so then now in the term of tangent x, meaning that we don't want to see any secant x left. Okay, so do you still remember the trigonometric identities? For example, sine square x plus cos square x equal to 1. Okay, so divide by sine square, sine square divide by sine square equal to 1. Oh no, it's not divide by sine. We're going to divide by cos. Okay, sine square, okay, everything divide by cos square x. So sine square divided by cos square equal to tangent square x. Cos square divided by cos square equal to 1. 1 over cos square equal to secant square x. So look at this one here now. Tangent square x equal to secant square x minus 1, or secant square equal to tangent square plus 1. So 1 minus secant square. Secant square equal to tangent square plus 1. Tangent square x plus 1 plus with tangent square x and another secant, which is tangent square x plus 1. Okay, now 1 minus tangent square x minus 1 plus with tangent square times tangent square, tangent to the power of 4x plus with tangent square times 1 equal to tangent square x. Okay, so then 1 minus 1 equal to 0. Tangent square minus tangent square. So what's left here now? Tangent to the power of 4x. There you go. Okay, determine the point of inflection of the curve this one here, fx equal to x to the power of 4 minus 2x cubed minus 1 using second derivative test. Okay, so let's say given here y equal to x to the power of 4 minus 2x cubed minus 1. Differentiate for the first time, 4x cubed minus 3 times 2 equal to 6x squared. Differentiate 1 equal to 0 then here. And then y double prime equal to 3 times 4 equal to 12x squared. And 2 times 6 equal to 12x. So now, we're going to find the value of x from the second derivative here. So let's make this one y double prime equal to 0, so which is 12x squared minus 12x equal to 0. Then 12x, which is x minus 1 equal to 0. With from here, then x equal to 0 or x equal to 1. So then, this value of x, just imagine that if I come up with this table, so there are two values of x, 0 and 1. Okay, just imagine that this is where x equal to 0 and x equal to 1. Okay, so let's find the range between this. This is the range for negative infinity until 0, 0 until 1, and 1 to positive infinity. So, just think of any value of x that lies in this range. Okay, make our life easier. Let's choose where the value of x equal to negative 1. Between 0 and 1, there's no other choices. Let's choose half, and this one here, 2. So then, f double prime, which is y double prime here, 12x squared minus 12x. Okay, class, substitute x negative 1 into f double prime, which is 12 negative 1 squared minus 12 times negative 1. And this one going to give you 1, and this one negative, negative, positive. So, 12 plus 12, 24, which is positive. Okay. Then next one, 1 over 2. 1 over 2 and 1 over 2. 1 over 2 square, it gives you 1 over 4. 12 divided by 4. Okay, 1 over 4. 12 divided by 4 equal to 3, and 12 divided by 2 equal to 6. 3 minus 6 equal to negative 3. Negative. And then, 12, 2 square minus 12 times 2. 2 square equal to 4. 4 times 12 is 48 minus 24 equal to positive 24. Positive. So guys, girls, we're going to look into a concavity. Okay, concavity for this one means that the mouth of the curve is facing up. Okay, the mouth of the curve is facing up. This one facing down and facing up. Okay, so it means that from here we can just imagine that the graph will be something like this. Here, here. Okay, so the point of inflection here at x equal to 0 and y equal to something, and here is 1 and something. Okay, so we're going to find out what is the point of inflection. Inflection means that the changing from the concavity facing up and facing down. So this is a point of the turning point between facing up and down. Okay, so how are we going to find the coordinate of this? Substitute into this function of y. So then y equal to 0 to the power of 4 minus 2 times 0 cubed minus 1. It gives you negative 1 here. Okay, so 0 and negative 1. So what about y when x equal to 1, then 1 power 4 minus 2, 1 cube minus 1. Okay, 1. 1 cube is 1 times 2 minus 2 minus 1. So negative 2 minus 1, negative 3 plus 1 equal to negative 2. So it is now is between the coordinate is 1 and negative 2. Okay, so that's it. So now let's go to the second part, part B of this question here. The first one. Okay, so the first one then here, Z1 equal to, okay, square root of 21. Okay, cos pi over 2. Just, okay, I sketch again the graph of cos, where cos begin at the origin point of 0, 0. Okay, we then maximum of y equal to 1 and the minimum is negative 1. So pi over 2 and then pi 3 pi over 2 and here is 2 pi. So pi over 2 cos pi over 2 according to this graph here, sketch here, it is equal to 1. So then cos pi equal to 1 plus sin pi. Sin pi, it begin, wait. Okay, sorry. This is for sin x and this is cos x. So sin pi, we call sin pi over 2 equal to 1. And cos begin from 1 here. Okay, maximum 1 and negative 1. Pi over 2 equal to 0. Pi over 2 equal to 0. So this should be 0 and sin pi over 2 equal to 1. 1 times I equal to an I. Okay, then the second complex number here, Z2 equal to 2 square root of 6. So cos 7 pi over 6 for this one here, find out which is negative square root of 3 divided by 2. And then minus with sine 7 pi over 6, which is 1 over 2 I. Okay, so now guys, girls, 2 divided by 2 here and also 1 over 2 here. So then you come up with square root of 6, negative square root of 3 minus an I. So then here now it is negative square root of 6 multiplied with square root of 3, which is square root of 6 times 3 equal to square root of 18. Okay, which I think that I'm going to simplify this way. I'm going to simplify this way here. 6 considered as square root of 2 times 3 multiplied with square root of 3 here. So square root of 2 times square root of 3 times square root of 3. So for these two, it become square root of 2 multiplied with 3. So then here now it becomes 3 square root of 2 minus square root of 6i. Okay. And then okay, find Z2 divided by Z1, Z2 divided by Z1, and leave your answer in set form. Okay, so now Z2 negative 3 square root of 2 minus square root of 6i divided by z1, which is square root of 21. Square root of 21, 0 plus I, which is I here. Okay. So now we're going to our mission here now is to clear this square root sign from denominators by multiplying with another of square root of 21i and square root of 21i. Okay. So then for denominator, square root of 21 multiplied square root of 21 equal to 21. And then I times I square. Okay. So negative 3 square root of 2 times this is going to give you negative 3 square root of 2 times 21, 42. Okay. And then negative square root of 6 times 21, which is okay. So square root of 6 times square root of 21, 1 times 6 equal to 6, and 6 times 2 equal to 12i. Wait, this one with this, we have I, and I with I squared. Okay, so negative 3 square root of 42 I minus, okay, this is I squared, which is negative 1. Negative times negative become positive, plus square root of 126 divided by I squared, which is negative 1, be divided by negative of 21. Okay, which I think that these are answers that the simplest that you can get here now. So then, modulus of Z2 divided by Z1 equal to, okay, this is the result of this. So then square root of negative 3 square root of 42 divided by negative 21 square plus with square root of 126 divided by negative of 21 square. Okay, so simplify these answers. Square root of, okay, so if you recall, find the answers from the calculator, substitute all the values inside, and leave the answers insert. Okay, next one. Now, we have e power of 2x minus e power of negative 2x divided by e power of 2x plus 5 e power of negative 2x equal to 1 over 4. Okay, this is an equation, so which I think that let's use that we call the cross multiplication. For this one here, come up with 4 e power of 2x minus 4 e power of negative 2x equal to 1 e power of 2x plus 5 e power of negative 2x. Okay, so look at this, e power of 2x and e power of 2x. So 1 bring to the side become negative. So 4 minus 1 equal to 3 e power of 2x. And e power of negative 2x, negative 4. 5 here, 5 positive bring to the side become negative. So negative 4 minus 5 equal to negative 9 e power of negative 2x equal to 0. Okay, so now let's say if I multiply everything here with e power of 2x, so then 3 e power of 2x multiplied with e power of 2x, it is 3 e power of 4x minus 9 e power of negative 2x, e power of 2x equal to 0. Multiply this, for sure I'm going to give you 0 in here. Okay, look at this one here now. E power of 2x multiplied with e power of negative 2x. So it's just like e power of 2x plus, because multiplication between these two with the same base here, then negative 2x. Okay, so e power of 2x minus 2x equal to e to the power of 0, which is equal to 1. So then 3e power of 4x minus 9 times 1 equal to 0. So it is 9 here, negative 9 here. So 3e power of 4x equal to 9. E power of 4x equal to 9 divided by 3 equal to 1 over 3. Oh no, it's 9 divided by 3 equal to 3, sorry. 9 divided by 3 equal to 3. So change in the log form here of log to the base of e of 3 here equal to 4x, or it is natural log of 3 equal to 4x, then x equal to natural log of 3 divided by 4. Okay. Okay, this is it. Then next question B here. Okay. 4 divided by x plus 1 less than or equal to x minus 2. So we are going to bring this to the left side. 4 divided by x plus 1. Okay, 4 divided by x plus 1. And minus, which is x minus 2 less than or equal to 0. Class, we are going to, assume that this is divided by 1. We're going to simply, equalize the denominator of these two. So we're going to need to multiply with x plus 1. And also on the top here, multiply with x plus 1. Okay, so 4 minus x minus 2 with x plus 1. Everything here divided by x plus 1 less than or equal to 0. Okay, so then 4 minus x times x, x squared. Okay, x with 1, x minus 2x minus x, and negative 2 times 1 equal to negative 2 divided by x plus 1 less than or equal to 0. Open up the bracket here. So 4 minus x squared plus x plus 2 divided by x plus 1 less than or equal to 0. Then we get negative x squared plus x. 4 plus 2 equal to 6 divided by x plus 1 less than or equal to 0. Okay, so now let's simplify this. Okay, if I multiply, okay, never mind, which is negative, okay, negative x and x, because the result of this is negative 1. So one of these x must be in negative mode then here. So negative x times x. So we got 6. 6 between, is between, 1 and 5 or 2 and 3. Okay, so for this one, which I think that is better, okay, with 2 and 3. Again, negative negative x multiplied with x, negative x squared. Negative x times 2 minus 2x. 3 times x equal to 3x. 3x minus 2x, x. Okay, and 3 times 2 equal to 6. So now we have 3 different linear factors. So let's assume that everything is positive. Negative x plus 3 greater than or equal to 0. Now, no, x plus 2 is greater than or equal to 0. But for denominator, it cannot be equal to 0. So then x plus 1 greater than 0 only. Then, and this one, negative x greater than equal to negative 3 and x less than or equal to 3. X greater than equal to negative 2 and x greater than negative 1. So then we have three different value of x, which is 3, -2, and -1. So -2, -1, and 3. The first one here, x less than or equal to 3. Then next is x greater than or equal to -2. And x greater than -1. So we have positive, positive, and negative. So positive times positive is positive times negative, negative. Positive, 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 positive. Negative with positive, negative times negative, positive is negative. And here, negative times negative, positive times positive is positive here. Okay, then refer to this. The whole function of this is less than or equal to 0. So the numbers that less than 0 are all negative, right? So the final solution set here, final solution set is which is -2 until -1 union 3 to positive infinity. Okay. According to this one is open bracket. Okay, open bracket here, sorry. -2 to -1 union 3 to positive infinity. There you go. So now state the domain and range of the function in the diagram below. Okay. Okay, this is the function given here, and this is the graph. Now state the domain and range. So domain is all values of x. So according to this, it begins with x from, okay, x starting from 0 here, and then until the last one value of x here, which is 2 pi. So the domain of this function is from 0 until 2 pi. And the range of f, range is all about y. So the value of y here, the maximum is 2, and the minimum here is -2. So that is from -2 until 2. Okay. Given that hx equal to this, h cannot be equal to 2, find h not h hex and state the h inverse of x. So, question B, this is your hx equal to 2x divided by x minus 2. So, h not hx, which is equal to h, and hx is 2x divided by x minus 2. So for composite function, we are going to substitute the whole function of h into an x of the h. So which means that here it is now 2x divided by x minus 2. And substitute here these two, we call space here with 2x divided by x minus 2 and 2x divided by x minus 2. Okay. So now class, just imagine that if we simplify this, the denominator here, this is 2 divided by 1. Okay. So we're going to simplify this or equalize the denominator. So here we're going to multiply with x minus 2 and x minus 2. Okay. So then 2 times 2 equal to 4x divided by x minus 2. Divide by, okay, now 2, okay, since that we have successfully equalized the denominator x minus 2 and x minus 2, so then for the numerator, 2x, -2 times x minus 2x, -2 times -2 equal to positive 4. Divide by x minus 2. Then next, bring this for the denominators above here and make a recall, turn the position upside down. They now become x minus 2 divided by, okay, 2x minus 2x plus 4. Now, okay, x minus 2 divided by x minus 2. Then we have 4x. 4x divided by, okay, 2x minus 2x equal to 0. So what's left here now? 4. Then 4 divided by 4 equal to 1. So what's left here now? X. Guys, girls, do you still remember this composite function between f, for example, and gx? If the final answer of this, question here, finally, it end up with an x. Given to you a function of f and function of g, then composite of f and g. So we do it all the process, and finally, we get it final answer as an x. Okay, meaning gx is an inverse of the function of fx. So, according to this solution for question B here right now, we can come up with a conclusion that h inverse of x is a function of h itself, which is 2x divided by x minus 2. There you go. Okay. Next, a function defined by this one here now determined whether f is a one-to-one function. Okay, so for this one,